Okay, this is the P4 paper from June 2024. It's question number 2, and as we can see, this is a vectors question, vectors in 3 dimensions. It says, given that OA is equal to that vector, AB is equal to that vector, can we find the coordinates of the point B? Yeah, well, we can. What I'm going to do, just as part of my explanation, I don't know that I'd necessarily do this in the exam, but is to just draw out a quick sketch. Now it's 3D, so it doesn't really matter where I put these, but I'm going to say OA is here. This is not accurate, and I'm going to say OB is there. And obviously in 3 dimensions, I wouldn't be able to do this, but so there's OA and there's OB. And what it asks for, it tells me OA and AB and asks me for the coordinates of point B. So hopefully what you can see, even without knowing them, we can definitely say that OB is going to be equal to OA plus AB. Okay, if I want that vector there, it's the same as OA plus AB there. So that makes this relatively straightforward now. So OB is just going to be OA, which was 7, 2, minus 5, plus AB, which was minus 2, 4, 3. So if we add those two together, we get that OB works out to be 5, 6, minus 2. And let's just go back and check. They want the coordinates of B. So rather than writing that, point B then, if we know the position vector, point B is just 5, 6, minus 2. So that's part A done. Part B says point C has a position vector OC, obviously, where A is a constant, and it says that OC is going to be perpendicular to BC. And it says that there's 2 possible values of A. Let's see if we can work out what they are. So if I want to draw OC in, then if they're telling me that BC is going to be perpendicular to OC, then let's keep that going down, actually. I'm going to need that to look something like that. So that if this is OC and this is BC, that those 2 vectors, these 2 vectors here, are going to be perpendicular to each other. Okay, well, if those 2 vectors are perpendicular to each other, then let's work out BC first of all, so part B. If I want to work out BC, well, BC is just going to be BO plus OC. So that's going to be BO plus OC, or another way of putting it would be C minus B. So C was A 5 minus 1, and then that's minus 5, 6, minus 2 there. So what does that give us as my vector for BC? That's going to be A minus 5, that's going to be minus 1, and that's going to be 1 there. So that's BC. And if we have the diagram where BC is perpendicular to OC, then what we'll be able to say is, let's say this to the examiner, if BC is perpendicular to OC, then BC dotted, with OC is equal to 0, isn't it? BC dot, or OC dot BC, whichever way around, that's going to be equal to 0. So that's A minus 5 minus 1, 1, dotted with, and OC was A 5 minus 1. So the scalar product of those 2 has to be equal to 0. Right, the scalar product of those is A minus 5 times A plus minus 1 times 5 plus 1 times minus 1. That all has to be equal to 0. This is going to be a quadratic, isn't it? Let's just work this out. This A squared minus 5A minus 5 minus 1, which is a squared minus 5a minus 6 equals 0. At this stage here, I'd be very, very tempted to think that this is going to factorise. They've been able to design this question. So yeah, you could use a quadratic formula, but almost certainly I would be really surprised if that didn't factorise down there. So that's going to give me one possibility for a is 6. One possibility for a is minus 1. What did they say in the question? They said find both values, yeah. So they didn't limit it. There's nowhere saying that a has to be greater than 0 or anything else like that. Yeah, find the two possible values. So we've done that, which means we've answered the question. Okay, hopefully that all makes sense to you.